Hey guys, hope you're doing well today. I'm going to do some math with you. It's on multiplying and dividing inequalities today. The hardest thing about these problems is keeping track of, do I flip the inequality sign or don't I? So we're going to go over that a lot in this lesson. Alright? So first, when don't you flip the inequality sign? Okay? First, in any of the problems that you did the other day, you don't flip the inequality sign. When I say flip, I mean take less than, make it greater than, or greater than, make it less than. Okay, so you might be wondering, when do I flip that inequality sign? Well, you do not flip it when you're solving ones like last time. So if you had like x plus 2 is greater than 8, and to solve it, you would want to undo the plus 2 by subtracting 2 to both sides. You would not flip it. It's x greater than 6, okay? There's no reason to flip it. It doesn't make logical sense to flip it. So anything greater than 6 would make this true. Like, I could plug the number 7 in. 7 plus 2 is 9. It's greater than 8. Okay, so when you're solving an inequality, you're finding not one solution, but a range of solutions that will be true for substituting for x. So I could substitute 9, I could substitute 7, I could substitute anything more than 6 that would make this true. Another time you don't want to flip it is if you're dividing or multiplying an inequality. Okay, so if it was like 3x is greater than or equal to 9, and I go and solve this one, I would divide both sides by 3. Okay, to undo the multiplication, I'm using division. So I have x is greater than or equal to 3. Okay, so which makes sense. Okay, if I plug in, say, 4, which is greater than or equal to 3, 4 times 3 is 12, which is greater than or equal to 9. Okay, so it doesn't make sense to flip it in this case. Let's see when you do flip it. All right, so one instance when you do want to flip it is when you're rearranging the inequality. Okay, so for example, you're taking the left side and you're flipping it over to the right side. Say if I had 7 is less than 8, okay? I could have a true statement if I wrote 8 is greater than 7, okay? 8 is greater than 7 is the same basic statement as 7 is less than 8. Now, when you're working with letters, it doesn't make as much sense to you intuitively in your mind, okay, to do that. But if I have x is less than 8, I could also write 8 is greater than x, okay? Typically, you want to write it like this for your final answer, and it's easier to graph when it has the variable first, okay? So I would, if the variable is on the right side, flip it to the left, flip the symbol, put the number on the right, okay? The other times you want to flip it is when I multiply both sides of an equation by a negative, or I divide both sides of an equation by a negative. Okay, and now it is both sides of the equation. It's not just if there is a negative somewhere in the equation. It has to be what you're doing to undo the equation on both sides. So an example of this one would be like negative 4x is greater than 16. Okay? So I want to get rid of the negative 4 times x, so I'm going to undo the multiplication negative 4 by dividing by negative 4. So I'm going to divide both sides by negative 4. Okay. Now, as soon as I divide both sides by negative 4, that actually changes the value of the inequality. So it's no longer greater than, really, at this point. It will actually change to be x is now less than a negative 4. Okay? X less than negative 4 makes this true. Okay? So for instance, what would make this true then? So you could test it out with a value. So test check here. You could use negative 5, okay, for x. So let's say x equals negative 5. You would plug negative 5 back into the original problem. And let's check to see if it works. The negative 5 times negative 4. Negative times a negative is a positive 20. 20 is greater than 16. Okay, so you see how by flipping the sign, okay, it makes sense. If you don't flip the sign, you know, the answers that you could have won't make sense. All right, so you can actually experiment with this and kind of prove why it makes sense with some actual numbers. Okay, so the reason why we need to flip it is so it keeps the inequality true. Like, for instance, if we had 10 greater than 1, okay, everybody agree that 10 is greater than 1. Let's just, for the fun of it, divide it by a negative 1, okay? If we divide 10 by negative 1, we get negative 10. We divide 1 by negative 1, we get negative 1, okay? Now, if you don't flip it, you would say the number negative 10 is bigger than the number negative 1, which doesn't make sense. So you have to flip it in order to keep the truth value by it, all right? So you must flip it in order to make it logically true, all right? So here's a bunch of examples. I hope this helps you, give you a good illustration of when to flip and when not to flip, okay? So, after each question, I'm going to pause it, and then you guys, pick, do you flip, do you not flip, all right? And then we're going to actually graph the solutions. The solutions represent all the possibilities that would make it true. So if you have this inequality here, d divided by 7 is greater than 15. Okay, so what do you think? Flip or not flip? All right, I think you got it. This one, you don't flip. Okay, why? Because in order to solve this one, you want to cancel out a positive 7. And what you're doing on both sides is multiplying or dividing by a positive. When you're multiplying and dividing by a positive, you don't flip. If you're multiplying and dividing both sides by a negative, you do flip. Okay, here we're multiplying by a positive, so we don't flip. All right, so we have 15 times 7. So D is going to be greater than 105. D is greater than 105. Just wanted to double check that one. Okay, D is greater than 105. Now, let's actually graph what that would look like. Okay, so graph the solutions. So, if I'm doing a little simple graph, I just put the number of the solution for our inequality. Now, this is not all the solutions, 105. Okay, 105 actually is not a solution to the inequality. 105 is like the border between the solution land and non-solution land, okay? So on this side, we have 104. So we want to represent with our graph everything greater than 105. So on our graph, we're going to shade everything greater than 105. At 105, because 105 is not included, we're going to use an empty circle to show that that actually isn't a point of solutions. Okay, so our solutions go this way. So this, in essence, is our solution land here, okay? Over here, this is bad land. No solutions over here, okay? No solutions over on that side. So this represents your solutions, this side doesn't. Okay, let's do another one here. 5x is less than negative 12. So in this one, what do you think? Do we flip or do we not flip? All right, so the answer is for this one, you do not flip again. Why? Because what you're doing to both sides is not involving a negative. You're dividing both sides by a positive. Now, there is a negative in the problem, but that is not what you're doing to both sides, so you do not flip. Okay, so we have negative 12 fifths, which you could write as, take 5 and a 12, that's 2. Okay, so you have 2 remainder, so that would be negative 2 and 2 fifths. Okay, all right, so let's graph what this one looks like. So here's your graph. I'm going to put negative 2 and 2 fifths here. All right, so let's think. What's to the left of negative 2 and 2 fifths? First whole number is negative 3, okay, leftwards. So, the numbers are getting bigger number-wise, but in value, they're getting smaller that way. Negative 2 would be the next one on this side. So we're going less than negative 2 and 2 fifths. So once again, we're not including that. This time, less than we're going to the left. Okay? Let's look at another example here. All right, so what do you think? Flip or not flip? Boom. All right, this one we are flipping it because we're dividing both sides by a negative. So we divide both sides by -5. X is now going to be less than or equal to -3. Okay, let's graph it real quick. So we put -3 there. Left of -3 is -4. Right of -3 is -2. Less than or equal to. First time we're doing that one. Because it's equal to it as a possibility, we want to darken the dot and we're going to shade to the left. Okay, because it's less than or equal to. Okay? All right, let's look at the next one here. Do we flip or do we not flip? Yeah, this one's an interesting one. You actually flip this one twice if you want to put the variable on the left side, all right? So what I would do when I see a variable on the right side, I would first rewrite the equation so that my variable is on the left side. It makes it easier to graph when you do this, okay? You can wait till the end to rewrite it if you want, but I'm going to rewrite it at the beginning. Okay, so I have -19.2k, which is now less than, because we switched the sides, 149.76. Okay? So to solve this, we're going to divide both sides by a negative. And so since we're dividing both sides by a negative, flip again. Okay? It's the double flipper. You're going to flip it twice. So we're going to flip this one again. And we'll end up with k is greater than, so originally was greater than, we flipped it to less than, came back to greater than. If we divide correctly, we get k is greater than 7 8/10. Okay, 7 8/10. If you have a positive divided by a negative, actually it's probably -7 8/10, yes. Sorry, typo there, -7 8/10. Okay, let's graph it then. We got greater than -7 8/10, so we have -7 8/10. -7 on this side, -8 on this side. You actually probably should be more closer to -8, but that's okay. We're going greater than, so here's a dot, and we're going that way. Okay, oops, I made a mistake. This should be an open circle because it's greater than -7 8/10. Okay, hope that makes sense. Let's look at another example here. We won't actually graph this one, but think flip or not. This one is another one where you need to flip because you're dividing both sides by a negative. Okay, so this less than or equal to becomes a greater than or equal to, and then negative divided by a negative ends up being a positive. This one ends up being positive 19. Okay. When you get numbers this big, you want to, if you struggle with dividing, use a calculator, all right? That's okay for numbers this big. Okay, this one right here, let's see. Flip or not flip? This one, another case where you're going to flip because you're multiplying both sides by -0.5 to undo the division. So multiply both sides by -0.5. Okay, and that's basically taking half of 12, so that's going to be 6. Okay, half of 12 is 6, and so you now have k is greater than 6. All right, last one here. Flip or no flip? This one, you don't flip because you're just getting rid of this 5/4. Now, how do you get rid of a fraction? Well, you actually, you can divide by a fraction, but instead of dividing by a fraction, instead you can multiply by the reciprocal, which is 4/5. So you're going to multiply both sides by 4/5, make this into 25/1, cross the diagonals off with dividing the diagonals. 5 divided by 5 is 1. 25 divided by 5 is 5. So I have 5 times 4, which is 20. So everything here is going to cancel. I have h is greater than or equal to 20 as my final solution. Okay? Hopefully those examples helped you. Hope you guys have a great day. Take care now, and God bless. All right? Bye-bye.